All right, now we're going to be looking at a word problem, putting all of our normal distribution together. Heights of apple trees in an orchard normally distributed, mean of 3.42, standard deviation 0.21. So we know that means we've got norm 3.42, standard deviation 0.21, so we write it with the squared, and these are for our x values, our probability. So write down the probability that a tree has a height greater than 3.42. Well, let's look at our picture. We know 3.42 is in the middle. So probability that a tree is greater than 3.42, well, that's half the graph. So that probability is 50%. Don't even need my calculator. And this said greater than, so I don't need the equal to, but remember for normal distribution, the greater than, or equal to, it doesn't matter. Probability within 2 standard deviations of the mean. So I've got my mean plus 2 standard deviations. So that's going to be 3.42 plus 2 times 0.21. Put that in my calculator. Let's get a clear screen. 3.42 plus 2 times 0.21. 3.84. And then my mean minus 2 standard deviations. Minus 2 times 0.21. Nice and easy to put in my calculator. Go up and copy it. Change the plus to a minus. Okay, that's exactly 3. So now I know I'm thinking about my picture. 3.42. The low number is 3. The high number is 3.84. And I remember that's something around 95 or so %, but I can use my calculator. So now I'm going to draw that. Shade norm. Oops, first I want to think about my window. Now 3.42 is my middle, so I'm going to go from 0 to 7. And then my y-min has been, or my y-max has been really high. I haven't seen much, so I'm going to make that 0.6. All right, now I'm going to draw my distribution. Shade normal. My lower bound was 3. My upper bound, 3.84. Mean, 3.42. Standard deviation, 0.21. I'm going to go to a different color. Navy, ooh, light blue. All right, so there we are. That's funny, I made it lower and now it did go up higher. But I can still see that my area, 0.9545. So my probability that I'm between 2 standard deviations is about 0.9545 or 955. Okay, use my GDC to calculate the probability. So I want probability height greater than 3.35. So now we want the probability that x is greater than 3.35. My picture, 3.35 is to the left of 3.42. So let's put that in. 3.35 would be somewhere around here. So I know this is going to be greater than 50%. Well, let's put it into my calculator. Low bound, 3.35. Upper bound is infinity. But the way I put infinity in my calculator, so quit. Let's go back to the drawing and clear out the drawing. Okay, let's go to my window and make my y higher this time. So I'm going to go up to 1. And now let's come back to my drawing. 3.35 is my minimum. my maximum, I'm going to say 1 times 10 raised to the 99 power. I just want a really big number. 3.42, 0.21. Okay. So now my area is 0.999571, so almost 100% of the area. I've got so little of this left that my probability 0.999571. Well, if I'm going to round that, that's going to round to 100%. So almost 100% of the apple trees are within that height. Right now, the probability that it's less than x is 0.65. So now we have, there's our 3.42, 0.65, whoops. So less than x, I'm going to shade this side. 0.65 is greater than 50, so I know that my x value must be somewhere over here. So it must be bigger than 3.42. Make sure that looks like a 4. So now we know that this probability, 0.65. All right, so this is the probability that x is less than little x is 0.65. This is the way I like it for my inverse norm. I don't need to do anything else except calculate it. So distribution, inverse norm. That's funny. Let's clear that. So distribution, maybe it doesn't like to go from the graphing screen. Inverse norm, all right, so my area is 0.65, 3.42 is the mean, and 0.21 is the standard deviation, and we get our value of 3.5, which is to the right like we thought. If we round to 3 significant figures, it's 3.50, because rounding the 0 keeps it a 0.